Welcome to the Math Center. In this video, we calculate the boundaries of a normal distribution. Before I go on, please make sure that you leave a like so I can brag to my daughter that I'm a YouTube creator and I can boast at parties and to my coworkers about how many likes I get on YouTube. In some cases, you'll be given a set of data that is described as being normally distributed. You'll also be given a percentage related to the amount of data, and then you need to calculate the boundary of what fits that percentage. So let's get started. The average annual salary of occupational therapists is normally distributed. The lowest 15% of salaries are less than $59,000. The top 10%, or the lowest 90%, realize that when a question tells you the top, really what you need to focus on is the bottom. So the top 10%, or the lowest 90%, is more than $76,620. Since this is a normal distribution, you're almost always going to need the normal average and the standard deviation. So part A in this question lays it out for you. You actually need to find what is the normal average and the standard deviation. Part B wants to know what is the probability that an occupational therapist learns less than $55,000. And finally, what salary separates the top 3% from the remaining or the lowest 97%. When we look at this question, we have to realize that what we're looking at are the salaries. Those are what the percentages are related to. They're not related to the number of people. Salaries are continuous data. It does make sense to have $59,000.55, but it does make sense to have 13.5 people. So continuous has decimals. Discrete, as we noted earlier, does not make sense to have decimals. Discrete data only has whole numbers. Part A requires solving two equations and two unknowns. However, this is another video. Regardless, let's get started on building the equations. Our z-score is equal to z equals x minus mu over sigma, where mu is the normal average and sigma is the standard deviation. As it happens, we have two cases. So our first z-score is equal to x first bound, or x1, minus mu over sigma. Our next z-score, which is exactly the same equation, which is z equals the second boundary, x2, minus mu over sigma. You'll notice that the mu and the sigma, they haven't changed. Regardless of where they are in the equation, they're exactly the same number. This is why I was saying we have two equations with two unknowns. I definitely have two z equations, and the mu and the sigma I do not know. Let's look at the first boundary condition. So z1 is equal to x1 minus mu over sigma. The question states the bottom 15%. So in this case, p is equal to 0.15. We'd have to find the z-score that's associated with 15%. Which means that we're going to have to look inside our z table. In the z table, we can see where the 15% is. If we look in the z table, we'll see that this value is 11.12%. This is 3.15%. That's not right. When we look in the z table, these values are pretty close. 0.1469 is not as close as 0.1492. As it happens, 0.1492 is closer to 15% than 0.1515. So I'm going to use that value. So it's -1 and 0.04. So my z-score is equal to -1.04. So the z-score for my first boundary, or my z1, is 1.04. Now remember, our first boundary was 59,800. So that's why I'm plugging in that number here. Now you're not used to seeing variables on the bottom, so we're going to change that. As a result, this sigma is going to move to the other side. If it's division on one side, it becomes multiplication on the other side. Now this equation is important, just not right now, so don't lose it. Now we'll deal with the second group, or the second boundary condition. The top 10%, or as I said, the bottom 90%. So we need to find the z-score when the probability is equal to 90. So as before, we refer to our z-table. So the z-table shows the probability. So we're looking probably in about this area. And we see that that one is the closest. So that's what we're going to choose. So our z-score is going to be 1.28. Remember, the boundary for the top 10% was 76,620. So our z-score is equal to boundary minus the average over the standard deviation. Remember, we're talking about the second group, so the second boundary. Now we just plug in our values and rearrange. Remember, I don't want the sigma on the bottom, I want it on the top. And it's a division on one side, it becomes a multiplication on the other side. And now we have our second equation. Now I have two equations with two unknowns, and let's pretend that I went through that process of solving two equations with two unknowns. As a result, I now have my mu and I have my sigma. So my average, or my mean, is 67,340. If I were to sketch that out, my mean would be in the middle. So question B wants to know what is the probability, which is part in here, that it's less than 55,000. So my boundary would be 55,000. So we'd have to calculate the z-score again. And mostly it's just plug and chug now because we know the boundary is 55,000, we know the average, and we know the standard deviation. So our z-score ends up being negative 1.70. Now we can refer to our z-table. So negative 1.7 occurs as 0.0, so it's going down. There's this one here. So that area is 0.0446. So the probability is equal to 0.0446. So the probability that you make less than 55,000 is 4.46%. Part C, or the final part, wants to know what the salary is that separates the top 3% from the remaining 97%. Or another way, let's find the salary that only 3% make. So let's visit the sketch. So I want the little area that is in here, because that is the top 3%. Where does this line occur? I need to find the boundary. So the equation that has the boundary condition in it is z is equal to x minus mu over sigma. So I am looking for x. I need to find the boundary. So I have to rearrange this equation. So the x has to be positive by itself and on the top. Nice thing is the x is already positive and it's already on the top. We just have to make it by itself. So remember, the sigma has to go to the other side, and the mu also has to go to the other side. So the sigma is division on one side, so it has to become multiplication on the other side. and the mu, subtraction, so it has to become addition on the other side. We've already got the values for sigma and for mu. We just need the z-score. So we know that our probability is equal to 0.97. So we just have to find the z-score based on our z-table. So 97% occurs somewhere in there. Actually, this number is closest, so we're going to use 1.88. Now it's just plug and chug because now we're going to use the formula z sigma plus mu is equal to x. We plug in our numbers, and now we know that only 3% make more than $80,970. I hope that helped. Please leave a like so I can boast to my daughter that I'm a YouTube creator. Talk to you soon.